Recording. Okay, good morning, guys. Yung lesson natin for today would be direct current circuits. Ibig sabihin ng direct current, ito yung direct current circuits. Ito yung mga circuits na merong source na hindi nagbabago with time. Okay? Yung kabaliktaran nito would be alternating current circuits. So yung alternating current naman, ito yung mga sources na nagbabago yung sinusupply nila through time. Okay. In our household, outlets, yung lumalabas doon alternating current dahil hindi siya kasama sa topic natin ngayon. Pero mas efficient yun kapag less. Okay. Lesser yung loss kapag alternating current yung binibigay sa atin ng power grids. Okay, na Meralco, ganyan. Or kung nasaan man tayong lugar. Okay, so this is just a continuation of the circuits topic that we discussed nung Monday. Di ba? Thursday ngayon. Tama ba? Thursday na ba ngayon? Okay, yan, sabaw ko na. Tapos na yung patapos na yung week. Okay, first, kailangan natin, di ba from last time, ginawa lang natin is a single resistor system. Now, when we have multiple resistors, ang mangyayari, pwede mo silang i-simplify. Okay? So, we need to have techniques to simplify them, and we have this kind of simplification. Okay? Okay. Meron tayong mga resistors in series and in parallel. Okay. Minsan nakakalito pag minsan nakakalito pag weird yung drawing. Pero kasi pag ganito yung drawing, madali natin naiintindihan na ito ay yung series, ito yung parallel. Okay, kasi literal silang parallel, di ba? Minsan nakakalito pag hindi na ganyan yung drawing. Okay, so dyan, a rule of thumb would be pag series, imagine niyo yung isipin nyo na yung head nila nakakabit sa tail ng isa. Okay? So, head to tail yung connection nila. So, yung tail ni, yung puwet ni R1 nakakabit sa ulo ni R2. Tapos yung puwet ni R2 nakakabit sa ulo ni R3. And so on and so forth. What would be, what would be weird? May mga weird na, itsura ng circuits. Kuwari, ganito na. Kuwari, ito example natin. So, di ba dinrawing lang siya ng weird, pero in essence, ganun pa rin siya. Yung magkakabit yung head and tails nila. Okay? So, not very intuitive kapag tinignan mo siya. Pero, tandaan mo lang yung rule na head-to-tail connection. Tapos, babaybayin mo lang siya. Then you can see that they are in series. Okay? Kapag parallel naman, they share the same, dapat satisfied yung dalawang condition na they share the same head and the same tail. Okay? Mapansin nyo dito si R1, si R2, and si R3, magkakabit yung mga ulo nila at puwet nila. Okay? Okay. Okay. Now, syempre, meron tayong mga combination ng series and parallel. So, meron kunyaring ganito. Let's have a sample circuit. So, this is +1. Yan. Pangit lang ako mag-drawing, guys. Pero resistor yung mga yan. Okay? R. Alright. Okay. Okay, let's, himayin natin. Sino yung mga naka-series, sino yung mga naka-parallel. So, this is a combination of a series and parallel connection. Tingnan natin kung sino yung which is which. Okay, so sundan mo lang yung line mula sa source. Dadaan ako. Okay. Tinamaan ko yung head ni yung uno. Lagyan natin mga pangalan. R1, R2, 3, 4. Okay. Pumunta ako kay R1, tinamaan ko yung head niya, then lumabas ako sa tail. Tapos, tatamaan ko yung head nitong triangle. So, R1 is in series with R2, R3, R4. Yung combination nitong lahat ng to. Okay? And then, pagpunta ko dito, si R2 and R3, they share the same head but they don't share the same tail. So, okay. Alam ko na hindi parallel sila R2 and R3. Alright? Okay. Tingnan ko ngayon yung daan ako dito sa R3. Pansin ko that magkakabit yung tail ni R3 and yung R4. Therefore, si R3 and R4 is in series. And then mapapansin ko na si R3 and R4, itong combination nilang dalawa, magkakabit yung head niya with R2 and magkakabit yung tail niya with R2. Okay? So R3, the combination R3 and R4 would be parallel to R2. Okay? Kasi hindi na intuitive yung drawing niya. Mahirap na siya ngayon intindihan. So gagawin nyo lang yung ganun. Babaybayin nyo slowly. Okay? And when we have resistor in a series, pwede mo silang pag-combine-combinein. Okay? So this, for the resistors in series, pwede natin itong i-simplify as into one resistor. Okay. In terminal, same pa rin, A and B. But this becomes our equivalent. Okay, with this equation. So series, madali. You just add them up. R1, R2, R3. No problem with that. In parallel, it's not very easy to do. Okay, kasi 1 over R equivalent must be equal to the 1 over R, 1 over R1, 1 plus 1 over R2, plus 1 over R3, and so on and so forth. Okay, how do you do this? How do you type this in your calculator? Para madalian kayo sa calculators nyo, yung R equivalent is just, okay, you type them normally. 1 over R1 plus 1 over R2 plus 1 over R3 and so on. Then you add your parentheses. Okay, so you do that. Tapos pindutin nyo lang yung negative 1 na power dun sa calculator. So this guy is equal to this one. Okay? Okay, makes sense naman, di ba, na pag in-inverse mo yung both sides, yung left-hand side magiging ganito na lang. Tapos ito, magiging ganito itsura. Okay, so you do this in your calculator para ito yung mahirapan. Okay? So again, yung resistors in parallel, you can simplify them similarly. So A and B. And this is our equivalent. Okay? So what is the R equivalent for this guy? R equivalent for this guy is somehow like this. So alam ko na si R3 is just in series with R4. Okay? And then R3, the R3, R4 combination is in parallel with R2. Okay, sulat ko lang muna ng ganyan. And then, sabi nga natin, si R2 and R3, si R2, R3, R4 combination is in series with R1. So I write them down. Now, explicitly, in equation informally, we can write this as R1 plus, since this is a parallel connection, so that yung parallel formula ko. So I have something like this, 1 over R2. I-add ko lang yung mga parallel terms. And then parallel with R3, R4. So 1 over R3 plus R4. And then that's all that is, that's all there is. Okay. -1. Then I'm done. So this is the equivalent resistance for this whole thing. And now I can rewrite my, simplify my circuit into one resistor circuit. So this is our equivalent. Okay? Okay. So yung connections niya, saan nagko-correspond? A, B. So dito, yun. Dito sa point na to, sa point na to. A, B. Okay? Alright, let's try another example. Let's try an example. Okay, let's try to solve this circuit. So yung source mo, 18 volts. Negligible yung internal resistance. So R is equal to 0. Then we have a 463 ohms in this configuration. Okay. Now, to do the VIR equation, since alam natin, si C hindi natin alam, di ba? Hindi natin alam si C. Pero si A and B, alam natin yun. A and B. So that's 18 volts. Kasi dumaan lang naman siya sa wire. So nothing changes there. Dumaan lang naman siya sa wire. Nothing changes there also. Therefore, yung kung may A prime ka dito, B prime. So yung VA prime, B prime is just this one. And mapansin natin, since A prime, the connection A prime A is just wire, therefore, we have this to be like this. Okay? And then, to use this, VIR, pwede lang ang gagawin lang natin is to transform this into a single resistor. And then from there, magagamit na natin yung potential difference ng VAB. Okay, so let's do that. To transform this into a single resistor, I have my R equivalent. I could see that 4 is in series with this combination. So 4 is in series with 6 parallel 3. Parallel 3. Okay. And this is 4 plus 1 over 6 plus 1 over 3. -1. Inverse lang. So let's evaluate this. So this is just 4 plus 3 over 6. Right? Inverse. And this is 6 ohms. Okay? 3 over 6. In-inverse mo siya, magiging baliktad lang, 6 over 3. So that's 2. 2 plus 4, that's 6. Okay, we then have, let's rewrite the circuit. Now it all becomes like this, a single resistor system. Okay, our equivalent nga lang siya. Okay. So, ito ay 18, tama ba? 18 volts. Tapos, our equivalent natin is 6. Therefore, magagamit ko na dito yung V is equal to IR. So, that's 18. We have 6 and I6. Malalaman ko na yung current flowing through A to B. Okay, with this, I have I to be 3 ohms, 3 amperes. Okay, kasi 18 divided by 6, kuha mo yan, 8. Kuha mo yan, 3 amperes lang. Alright. And then we can proceed with calculating everything else. Now I could dismantle this R equivalent to something like this. Okay, i-dismantle ko ngayon pabalik itong simple circuit natin back to this original circuit para makuha ko yung other properties ng mga currents everywhere. Okay? Gusto natin kunin lahat ng mga sagot. So the left resistor is still 4 ohms. 4. However, yung simplified version nito, parallel sila, di ba? Ito yung nire-represent nun. So that's 6 parallel 3. 6 parallel 3. Okay. So yung 6 parallel 3 is just 2. 2 ohms. So lagyan natin 2. Okay, and then our 18 volts. Then we have a current flowing, circulating around this circuit with I is equal to 3 amperes. Okay. Now we can get the potential, yung C and B. Okay, VCB. Makukuha natin yung VCB. Kasi hindi natin alam si CN, di ba? Kaya natin ito ginagawa. Kasi we don't know C. So VCB is just I, R. So this is 3 times 2. Okay, kasi tinitignan natin yung nandito. Right? Alright. So, ito ay 6 volts. Okay? So, sa VCB, meron siyang 6 volt na kinoconsume. Now, I could dismantle this again, so that we can go back to the original circuit. And let's do that. So, then again, meron akong ganito. Tapos si 4. Tapos madi-dismantle na yung parallel. So, I have 2 circuits here. Two resistors here, I mean. And then like that. Okay, and then 6 ohms and 3 ohms. So 6, 3. Now I don't know what currents are flowing in them. Okay, alam ko lang yung total current na dumadaloy sa kanila. which is 3 amperes. Kasi, okay, may 3 amperes na dumadaloy dito. Then, mag-split up siya. Then, reconnect with at the end. So, alam ko lang, may pumasok na 3 amperes, may lumabas na 3 amperes. I don't know kung sino sa kanila yung mas may kinuwang current. Okay? Okay. So, pero alam ko na ngayon yung potential across them, which is yung VCB. So, this, pinangalanan natin itong C, tapos pinangalanan natin itong B. Okay. So, I can use again my VIR. V is equal to IR. 6 volts must be equal to, tanggalin muna natin yung units. 6 must be equal to meron akong dalawang equation. Okay. 6I. Okay. Tinitingnan ko ngayon, since parehas sila ng parehas sila ng head, parehas sila ng tail. Again, yung potential, magiging parehas lang doon sa wire kasi wala namang nako-consume yung wire. Therefore, they would share the same VCB. Okay? They share the same VCB, yung 6 and 3 ohm resistor mo. Ang problema lang, di natin alam yung current flowing in those arms. So you have two equations now para dun sa 6 ohm na arm, para dun sa 3 ohm na arm. Okay, then we can find I to be 1 here, 1 ampere. For this case, 2 amperes. Okay. So meron kang 1 ampere. And then here, 2 amperes. Here, meron kang 3 amperes. And that makes sense, no? Kasi 3, na breakdown siya into 2 and 1. Okay? Magulat ka pag sagot mo 2 tapos 2. Kasi sumobra siya, di ba? So, lahat ng papasok, ganun din yung lalabas. Okay, so we solved lahat ng currents and all. Okay? So, you have this. Okay. Let's try another example. Meron daw tayong dalawang light bulbs. Meron silang resistance na 2 ohms. Connect mo sila sa source na 8 volts na walang internal resistance. Tapos, ang tanong sa atin, hanapin daw natin yung current through each bulb, potential difference across each bulb, and the power delivered to each bulb. Okay. Kapag yung bulbs are connected in series and then in parallel. Okay, so first things first, ano yung series. Okay, kakabit mo lang daw si source and bulbs in series. Okay, I would draw it like this. Okay, dalawa daw, di ba? Tapos in series, so sulat ko sila ng ganyan. Cute kasi pa-square, rectangle. And then 2 ohms yung lakas nila. 8V, 2 ohms, 2 ohms. Okay. So I could simplify this. Let's proceed. Para malaman natin yung current that is circulating around. I could simplify this into a single resistor. And by inspection, this is series. Add mo lang sila. So this is 4. 4. Tapos ito ay 8. volts, 4 ohms. Therefore, I circulating around, it must be 2. Okay? 2 amperes. Okay, para I times R magiging 8. Alright. Alright. Alam na natin yung current that is flowing. Therefore, makakuha na natin yung potential across everywhere. So, across the first bulb, I times 2. Okay? And in the second bulb also, I times 2. Therefore, potential difference, lagay natin yung pangalan. A, B, C. Okay, VAC, alam natin yan to be 8 volts. Then VAB is 2 times 2. So that's 4 volts. And then VC is just 2 times 2 pa rin. So that's 4 volts. Alright. So, nasolve na natin current everywhere, potential differences across each bulb. Now, the power delivered to each bulb. So, I squared R. Ay, P pala yung symbol. Energy palang W. Okay. PBC. Sa PAB, sa resistor AB, so I squared R, mangyayari, 2 squared, that's 4, times R, which is 2, so that's 8. And since same resistor lang din to, same current, 8 watts din ito. Okay, so that is all there is. Next would be parallel. Nangyayari, okay. Pag parallel naman, just draw it like this. This is 8 volts. 8 volts, 2, 2. Same specs pa rin yung resistors and source. Nakaparallel nga lang ngayon. Okay. Sige. Sorry. Ayan. Okay. Going back. Alam natin na, okay, lagyan natin ng mga pangalan. A prime, A double prime. So this is B prime, B double prime. Papansin nyo, si A prime, A double prime, nakakabit lang ng wire. Therefore, VAB must be equal to B A prime, B prime. And V A double prime, B double prime. Okay. Now I can use VIR, the Ohm's law, with each resistor to find the current that is flowing through here and here. Alright, so VA prime, B prime must be equal to I 2 ohms. And VAB, A prime, B prime is 8 volts. Therefore, I must be equal to 4 amperes. And then similarly, ganun lang din naman, uulit lang din naman. Therefore, so yung I, A prime, B prime. Pangalanan natin para hindi mahirap. I A prime, double prime B, double prime must be equal to 4 then. Okay, since 8 volts yung potential difference, then same naman yung resistor which is 2. Ganun pa rin yung calculations natin. 4 amperes yung lalabas. Next would be having the power calculated. So P is A prime, B prime. So this is I squared R. That's 16. 16 times 2. Okay? Kasi 4 squared is 16 tapos times 2 yung resistor. So that's 32 watts. B, A, double prime, B, double prime is similarly ganun din. 32 watts. Okay, yung tanong sa letter C, suppose one of the bulbs burns out. Okay? And current can no longer flow through it kapag na-burn out siya. So what happens to the other bulb in the series case and in the parallel case? Okay, ano mangyayari? Tingnan natin. If masira ito, ang mangyayari, mapuputol yung circuit mo, diba? Therefore, no current would flow. So, walang current na nagpo-flow, VBC mo, solve natin, ay 2. So, 0 times 2. So, 0 yung VBC mo. Walang potential na consumed in your 2 ohm resistor. Ang mangyayari, hindi siya iilaw. Okay? So kung baliktarin mo man, kung dito man yung ma-burn out, ganun pa rin dito, walang dadaloy na kuryente. Therefore, pag naka-series yung mga bulbs mo, what happens is that if one burns out, all of them goes out. However, a different case happens with the parallel configuration. Okay, if this burns out, and then what happens is that my VA prime B prime is still 8 volts. Still 8 volts. Okay, walang problem. Kasi nakakabit pa rin ako sa source. And then, wire lang naman yun. So, that's still the same. What if ito naman yung nasira? So, buhay pa rin yung wire ko. Buhay pa rin yung wire ko sa taas. Kakabit naman ako dito sa kabila. Okay. And amazingly, yung current will still be the same. It will still be the same. Kasi VIR, di ba? 8 is equal to I2. So, 4 amperes pa rin makukuha ko regardless kung mamatay ito o hindi. Wala akong pake sa kanya. Alright. So, usual connection yung parallel na para mas maganda yung yung practicality. Kasi wala silang pake sa isa't isa. Ang problema nga lang, pag dinamihan mo to. So, kanina kunyari nakabukas tong dalawa. So, each of them would have 4 amperes of current flowing through. So, kapag dinagdagan mo ng dinagdagan, nahihirapan yung source kasi kailangan niya mag-provide ng mas maraming current. Okay? So, para dun sa dalawang nakabukas na light bulb, there will be 4 amperes current. So, that's a total of 8 amperes flowing through. So, yung power going through the source would be VI. So, 8. Tapos, in total ko ay 4 plus 4 current. Therefore, this is 8 times 8, so 64 watts. Pero dun sa, kunyari, namatay yung isa, ang mangyayari lang is VI is 8 times 4 kasi isa lang yung nabubuhay. Therefore, this is just 32. Okay. So, every time na dinadagdagan mo siya, tumataas yung power na kailangan niya ibigay. Okay. So, we have that. Now, let's try a more, parang hassle na to eh, no? Hassle lagi na mag-transform ng into simpler circuits, 'di ba? Parang ang effort niya. So we have here is Kirchhoff's rules. Meron tayong dalawa, so that would be the junction rule or loop rule. Sa iba tinatawag silang KCL for this and then KVL for this. So si KCL ay Kirchhoff's current law and then the KVL would be Kirchhoff's voltage law. Okay, just naming. Ano lang naman ka? Naming lang. Alright. Ang gusto niya lang mangyari is that the current into any junction, so lahat ng current into any junction must be 0. And then the sum ng lahat ng potential difference around any loop must be 0. So ano itong loop and junction na sinasabi niya? Let's have a sample figure here where we can see what is a junction and what is a loop. Okay. So si junction, sila yung mga more equal to or greater than or equal to 3 connections. Okay. Okay. So si A is a junction, then B is also a junction. C and D is not a junction, pero. You can still use this to do you can still use the current law. Pero sayang effort nga lang. Kaya niyan, hindi tinawag na junction ito. Okay? Kasi makikita mo naman sa D, di ba? Siyempre, sa D mo, sum ng I, 0. So, lahat ng incoming, intuitive naman na lahat ng incoming, lalabas dun sa other side. Outgoing. So, medyo wala siyang sense kung gagawin mo dun yung junction rule. Okay? So, for the loops, ikaw magka-assign yan. Pwedeng counterclockwise, clockwise. Tapos dito, sa outside loop, meron din. Okay. Alright. Usually, hindi lahat ng loops useful. Merong mga loops na sayang effort lang. So, we don't, makikita nyo through examples. By experience siya nalalaman. Okay. So, pag hindi mo siya tinry, you might be wasting a lot of time. Let's try an example. In the circuit shown in here, meron kang 12 volts power supply. Hindi mo alam yung internal resistance R. Tapos nakaparallel siya sa, hindi, connected lang pala. Okay, bakit hindi natin masabing nakaparallel kasi yung head niya, yung plus, hindi nakakabit sa plus ng kabila. Okay. Hindi siya madaling i-conclude. Pero si resistor, alam mo, nakaparallel sa either of them. Anyway, wala namang combination dito na kailangan nun. Okay, so ang pinapahanap sa atin would be find R, yung potential nitong other battery, and the current through the power supply. Okay. So dito, ang madali sa kanya, nag-assign siya ng mga loops and current directions. Ayan. Pero given yung 2 amperes and 1 ampere. Alright. So, unahin natin yung unahin na muna natin yung junction rule. So, for junction, A, junction A, what happens there? Sige. How do we express this equation? How do we do this? Okay, ang usual kong ginagawa is that on the left-hand side, sinusulat ko lahat na incoming. And on the right-hand side would be the outgoing. Okay? So, pwede naman ganun or pwede rin na mag-a-assign ka kung sinong positive. Okay? You can assign incoming to be positive. Then you minus the outgoing. Okay? Or the other way around. Minus the incoming. Kung mas gusto mo siya, mas pasok siya sa intuition mo. Outgoing. Okay? Pero ayoko ng mga ganyan. Gusto ko yung ganito. Wala akong negative. Incoming must be equal to outgoing. Okay, sir, how do you make questions sa atin? How do you assign optimum current directions? So, try natin mamaya. Dito kasi naka-assign na yung mga current directions eh. Okay? So, let's try the hard example. Alright. Sige. So, gagamitin ko itong incoming is equal to outgoing kasi ito yung prefer ko. But you can always do your thing. Alright. So, at A, pansin mo, merong current na tumataas dito sa side na to. Therefore, wala naman siya ibang pupuntahan. Ganyan siya dito. And you have your 1 ampere going like this. And meron ka na pababa dito which tells you that it's going there. Okay, may isa akong outgoing, then dalawang incoming. So let me write that down. Meron akong 3 ampere incoming plus 2 ampere incoming pala yan. So 2 plus 1 must be equal to I. Wow, dali naman. Okay, I must be equal to 3 amperes. Okay, from that, masasolve ko na agad si R, yung small r, kasi di ba V must be equal to epsilon minus I R. Therefore, yung V ko is given 12 volts. 12 volts. Hindi pa pala natin mag-solve kasi walang okay, sige, hindi pa pala natin mag-solve. Asumera lang ako. Okay, kailangan pala muna natin gamitin ng yung loop rule. Okay, let me just do that. Loop rule. Okay, hindi na ako nag-proceed with junction B because I would get the same answer. Ang problema nga lang dito sa ang difference lang with junction B is that meron akong dalawang outgoing, may isang incoming. And similarly, makukuha mo yung ganitong equation. Okay? Wala na siyang sense kunin. Okay. Next would be loop rule. Okay. Loop rule would be like this. So, gawin natin for loop 2. Okay, so ito yung loop na yan. So, going clockwise. And then, so how does this work? Okay. Dito sa paggamit ng loop rule. Meron conventions si Griffiths. Ay, si Griffiths tuloy. Yung ano natin, si Young and Friedman for the, as a, for the sign conventions. Okay. So, sige, gagamitin natin sila. Okay. Okay. So, let's do that. Ang gagawin mo lang is that kapag kasabay mo yung current, kasabay ng loop mo yung current, negative siya. Kapag kasalubong mo yung current, positive siya. Nakakalito. Pero basta you are consistent, nothing goes wrong. Pwedeng mabaliktad mo sila, that's okay. Basta nabaliktad mo sila sa lahat. Okay? Tulad nga dito, you can see that there are many possible techniques to do it. Ganon din sa loop rule. You just have to be consistent. Okay, so let's do loop number 2. Okay, gagawin ko is that kasabay ko ngayon si 2 amperes sa loop ko. Therefore, negative yung Negative yung i-assign ko. So, negative IR plus may dalawa akong tatamaan dito. So, that would be my resistor. Okay, so ipa-plug in ko na yung mga values, no? Para hindi tayo nahihirapan. 2 amperes, 3 ohms. 2, 3, okay? 2 amperes, 3 ohms. So, ipaparenthesis natin yung resistor para hindi nakakalito. And then, next would be, sasalubungin ko yung current. So, that tells me positive yung assumption ko for the loop rule. Okay, so that's 1, 1. And then, meron pa akong isa, which is yung EMF ko. E. Okay. Okay. Pag sinalubong mo yung yung positive terminal ng EMF mo, ang mangyayari, negative yung makukuha mo. Negative yung makukuha mo na EMF. So, we have this. Okay, then all is equal to 0. I would just simplify. 6 plus 1 minus E. So, this is 0. Solve for epsilon. I have negative 5 volts. Okay, negative 5 volts. Suppose nakalimutan mo yung convention. No? Pwede ka na bumaliktad. Parang mas intuitive kasi na positive pagkasabay mo yung current, di ba? So you can do that. Wala namang problem. Mas intuitive na kasabay mo yung pag-positive pagkasabay mo yung current. Therefore, I have 2 times 3. And then, may makasalubong nga na current. So, gagawin ko negative. It's 1, 1. And then, susundan ko na lang yung tatamaan kong terminal. So, positive. Positive yung gagamitin ko. Di ba ang intuitive nun? Hindi kasi yun yung ginamit ko nasa libro. Ano ba yan? So, E must be equal to negative 6 plus 1. So, this is just negative 5. Same, yung nakuha ko result. Yeah. Pero, ayun. Ay, nako. Pangit nung ginamit na convention ng libro. Okay. So we have this. And then lastly, let's try another loop, which is loop rule. Loop rule at 3. Okay. Okay. Let's go. So, kabitin natin yung convention muna. Gamitin natin yung convention. Okay, may kasalubong ako na let's do this. Pag ano naman, clockwise naman ako. Yung una ko makakasalubong would be the resistor, 1 ohm resistor. Then, kasabay ko, therefore, negative. Negative 1, 1. And then, may makakasalubong ako sa negative terminal. So, gagawin ko raw positive, sabi ng libro. And then, for this one, dalawa yung makakasalubong ko. Okay, nakasalubong ko yung negative muna. Diba? Pa-clockwise ako. Negative muna, so that's plus 12. And then, lastly would be yung R. Okay, kasabay ko siya, therefore it's negative. Negative I R. So, from here, makikita natin, solve mo natin si R. Okay? Kasi given si I, nakasolve na natin si I, nasolve na natin si epsilon. Plus epsilon plus 12. Ay, plug in ko na yung values para hindi ako may. So, si epsilon would be negative 5. So, that is negative 5. And then I would be 3. 12 minus 3R. 0. So, this is minus 6. 6 minus 3R. 0. Therefore, R must be equal to 2. Okay? 2 ohms. Kalimutan ng units. Okay, nasolve na natin lahat. Di ba? Again, you just have to be consistent. Okay? Kung gusto niyo yung ginawa ko ng pangalawa, then no problem. You'd still end up with the same answer. Okay. Now, let's do this example. Itong bridge circuit. Ngayon, tanggalin natin yung assumptions sa mga circuit and loops and everything. Okay. Let's redraw the system. Tayo yung mag-assign ngayon. Kasi in the exam, di naman given usually yung mga directions na yan. So, ikaw yung magpapakahirap na mag-assign and mag-assume. Drawing ko lang muna. Okay. Almost done. Yan. Pero kunin natin yung mga pangalan. I1, I2, I3. Okay. Let's do this. I1. Then this is I2. I3. Okay. Whatever direction we choose. Pangalanan lang natin sila. I1, I2, I3. And then, hindi na natin pangalanan yun nandito kasi they would just be combinations of I1, 2, and 3. The resistors would be 1, ito lang na iba. 2, 1, 1, 1, 1, 1 ohm, 1 ohm. Okay. Okay. Then the source would be 13 volts. 13 volts. 13 volts. Ayan. Okay. Di ba kanina tanong sa atin, ano daw yung optimum current directions? Okay, so I do it like this. Hindi ko sure kung ito yung optimum. No? Kasi yung pagiging optimum niya depends on what you think is optimum. Okay? You can actually assign weird things to do like this. Okay, so lahat sila papasok dito. And you'd still get an answer that is correct. Okay? Okay. So usually what I do is lahat ng current, it's going out of the positive terminal of the battery, the source. Okay, so then mag-split up siya. I prefer to choose the same direction kapag dalawa lang naman yung pagba-branch outan mo. And then goes here. Okay, and problema na lang is to assign the direction in the middle, in the bridge. Okay. Kasi tinawag na bridge. Ang magandang gawin na magandang gawin na direction ng current is that pupuntahan mo yung least resistance. Okay? Puntahan mo yung least resistance. Therefore, kahit optional lang yan. You can always you assign the direction of the current towards the greater resistance, but magna-negative siya in the end. So, piliin mo na lang yun sa yung sa least resistance. Okay, kung mapansin nyo, meron kang 1 ohm resistor here, 1 ohm resistor there, and pagdating mo dito, same yung 1 ohm lang yung nasa bridge, o wala tayong pakidoon muna. Then yung two outcomes mo would be going to 1 ohm and going to the 2 ohm resistor. Sabi ko nga, punta tayo doon sa least resistance, so pakaliwa yung gagawin ko. Okay. Did we assign the same direction? Okay. Hindi. Okay, so we opposed actually the direction of I3. Okay. So let's do this. First things first, tapusin ko yung mga currents ko. So in this 1 ohm resistor, it would just be, kung gagawin mo yung junction rule mo, it would just be I1. The current here is just I1 plus I3. Okay? And then for the bottom one, the 2 ohm resistor, it would be I2 must be equal to yung I3, and then the other, yung hinahanap mo dito, itong nandito. So therefore, X has to be I2 minus I3. Okay, so let's just delete the calculations. Okay, so the current that is flowing in this arm is this. Okay, and then the combination of these two would be I1 plus I3 plus I2 plus minus I3. So therefore, I1 plus I2 itong bottom part. Does it make sense? Balik tayo stop. Okay, the total is I1 and I2. Okay, let's go. Let's start. Meron kang possible loops. Drawing natin yung mga possible loops. Usually, ang loop, sinasabayan mo na lang yung current mo. But you can go in a different direction. Okay, pwede ako magganyan. And then, pwede ako mag-loop dito. Pwede ako mag-loop dito. Pwede ako mag-loop dito. Okay. Okay, gamitin ko yung outer loop. Gamitin ko yung outer loop. Okay. So, ano yung convention ng author natin? Outer loop. What do we get for the outer loop? So, tinamaan natin, clockwise tayo, di ba? Tinamaan natin yung negative terminal 13 volts. Therefore, positive siya. Tapos, okay, kasabay natin yung dalawang current. So, that is negative. Tama? Dahil sa convention na ginagamit niya. So, this is negative I2 times 1. Okay, parenthesis ulit natin yung mga resistors. And then, the bottom leg would be sa bottom leg ko, makukuha ko I2 and I3 times 2. So, negative pa rin. Negative. Lagay muna natin yung resistor which is 2. Okay, and then, kailangan ko mag-parenthesis. I2 minus I3. That is all equal to 0. Let me just simplify. 13 minus I2 minus I2, dalawang I2. So, therefore, tatlong I2 ito. Tapos, distribute minus 2. So, ko plus siya. 2I3 must be equal to 0. Okay? And then, let me try the inner loop, which is this guy. Okay. Positive 13 dahil yung negative terminal lang tinamaan ko. Tapos, I have, kasabay ko na naman yung mga currents, therefore, negative silang lahat. I1. I1. Tapos, 1. Tapos, the other length, the other arm is 1 then. So, minus 1. Tapos, I1 plus I3. Okay, equal to 0. Simplifying, I have minus I1, tapos minus I1 dito din. So, dalawang I1 yun. And then, mukhang I1. Yan. And then minus I3. Okay, that is equal to 0. Drawing ako lang ng circle. Ayaw niya. So, wag na. Meron na akong dalawang equations. So, we have here for I2 and I3. We have here for I1 and I3. Then, what can I do? Ang gagawin ko, kailangan ko pa ng isang equation kasi meron akong tatlong unknowns. Okay, so let's try the loop. Let's try the loop here. Okay, wag na dito sa baba kasi dito sa baba, yung mga currents mo, combination siya ng ibang current. So, dito na lang tayo sa taas. Okay. So, dalawa yung dalawa yung kasabay ko. So, dalawang negative terms yung meron ako. Then, isa lang yung kasalubong ko. So, positive yun. So, we have the triangle loop. Okay. So 1 ohm lahat ng resistor. Therefore, ang mangyayari ay, sino yung mga kasabay ko? I2, negative. Then, negative din si I3. Positive si I1. 0. Tama ba? Okay, si I1 yung nakasalubong ko. Siya lang yung positive. Tapos nakasabay ko yung dalawa. Therefore, negative yung dalawa. I2 and I3. Okay. Sige. I could write down I1 as this. It might be useful for me later. I don't know. But maganda lang isulat na positive silang lahat. Okay. And then, in times like this, gamitin nyo yung calculator nyo. Huwag nyo solve naman. Huwag nyo isolve man. No? Okay. So, sulat ko lang muna yung systems of equations ko. I have I1 minus I2 minus I3 plus 0 equals 0. Okay, kinopya ko lang to. Lagyan ko lang dito ng something else na constant. Para lang magkakapantay sila. Next, I have negative 2 I1 minus 0 plus 0. And then, minus I3 plus 0. Ay, joke. Hindi na siya plus 0 kasi may 13 ka. And then lastly, ito. 0 naman yung I1 mo. So, I2 ko would be negative 3. And then, 2I3. Then 13. Okay, so you have this. You can plug this in your calculators. I think madali yung ganong way, di ba? Okay. Okay, sige. Okay. Iniisip ko solve ko na, is-solve natin ngayon ng by hand. Pero parang ayoko. Okay? Ayoko. Ayoko. Huwag na. I-calculator nyo na lang, no? Ang lalabas dito would be I1 must be equal to 6 amperes. I2 would be 5 amperes. And then I3 is 1 ampere. Okay? Sa libro nyo, ang nakuha niyang sagot would be negative 1 amperes for I3. Kasi yung inassign niyang direction, pakanan. Okay? So, yung pakanan na I3 na sinolve niya, lumabas, negative. So, therefore, pakaliwa talaga yung current. Tama yung assumption natin. Okay, and then the other currents follow. So, solve mo na lang siya. And as you can see, yung I1 natin, mas malaki kaysa kay I2. I1 is greater than I2. 6 amperes kay I1. 5 amperes kay I2. Kasi, sabi ko nga, yung current gusto niya dun sa least resistance. lesser resistance. Pansin mo sa right arm mo, may 2 ohms ka kasi dun. Kaya ayaw niya dun. Ayaw ng current dun. Okay. Alright. Yun lang. So, ayun, no? You just have to be consistent. Okay. So, asing topic, basahin nyo lang itong tatlo. Merong ammeter, voltmeter, ohmmeter. Baka kami lumabas na exam. We don't know. Okay. So, ayun. Paano sila gumagana, no? How do this, okay. Kasi ang main, ano mo dito, main point of curiosity mo dito. How would this tree measure? How would this tree measure without affecting the existing circuit? Diba? So, paano hindi maapektuhan ng ammeter mo yung currents dun sa system mo? How does it not increase the current for other parts of the circuit? Lalo sa voltmeter mo, paano siya hindi nakaka-apekto dun sa ano? Kasi di ba kunyari meron kang battery, resistor, another resistor, and say you want to connect a voltmeter, how does this not affect the voltage here? Di ba kasi parang nakaparallel siya. Parang nakaparallel siya dito. Okay, so wala ba siyang resistance to begin with para hindi maapektuhan to mga to pag kinabit mo siya? So, ayun yung mga point of curiosity. Inspiration for reading. Okay? And then, meron tayong in-skip na topic from the previous chapters, yung capacitors, yung capacitance and energy. Okay? Kasi feeling ko dito siya mas appropriate na ibigay. Okay. So, sa capacitors naman, in series and in parallel, kabaliktaran lang yung nangyayari. Yung equivalent ng capacitors for the in series, sila yung naka-reciprocal. Tapos kapag naka-parallel sila, ayan, sila naman yung nag-add normally. Okay. So, bakit anong rason, di ba? Anong rason? Kung maalala nyo, resistance is somewhat rho L over A. And then yung capacitance is epsilon A over D. Okay. Napansin nyo dito, kapag nag-i-increase ka in length, you just add. Okay. So, kung wari, intuitive analysis lang. So, kung bakit sila ganyan. So, may resistance ka na L, and nasa numerator sila, the length would just add up. So, kapag naka-series sila, parang ina-add mo lang yung mga bagay-bagay. However, kapag naka-series yung capacitors, mapansin mo na kung maglalapit-lapitin mo sila, lumalaki yung distance between them. So, yung distance, nasa denominator siya, kaya siya ganito. Kaya ganito yung itsura niya. Okay? And then, kapag nakaparallel naman sila, mapansin mo na yung haba nito lumalaki. Di ba? Parang nag-iisang ano lang sila. Tapos same distance, lumalaki lang yung area. Effective area. So, nasa numerator yung area. Kaya ito yung nag-a-add normally. Okay, wala lang. Ano lang. Intuitive analysis lang. Bakit? Para naman na bakit? Bakit sila ganun? Okay? So, yun yung intuitive analysis. Pero formally, you could Huwag na natin gawin for mathematical form, formally in mathematics. Okay? Ganun lang yung imagination for it. Kung bakit sila ganun. Alright. And then, sa naman sa mga capacitors, hindi tayo nagsosolve ng mga ganito usually. May certain lang tayo na sinosolve for our capacitor circuits. Okay, dahil mahirap isolve itong mga bagay na ganito. Okay. So, meron tayong isosolve na tinatawag natin RC circuit. Basically, ito yung R, yung sa resistor, plus C, capacitor. So, it's a combination of R and C. Okay, and then simple lang yung gagawin natin, which is yung charging and discharging lang. But in the deeper discussions of RC circuits, marami pa nangyayari. Not just charging and discharging. Okay? Okay. Alright. For charging a capacitor, mangyayari, literal na i-charge mo siya. No? Kasi di ba kung naalala nyo, yung capacitors, they would store energy. Okay? They would store energy. So there must be a way of charging it and discharging it. But here we have two circuits. So kapag naka-open yung switch mo, walang charging na magaganap kasi wala kang current na dumadaloy, di ba? Wala kang current na dumadaloy. So kapag kinlose mo na yung switch, magiging closed na rin yung circuit mo. Mag-current na mapo-flow. Therefore, magkakaroon ng build-up ng charges doon sa capacitors mo. Therefore, it would be charged. Okay? Okay, so how do we do this? Let's try to solve it. Okay, so ang gagawin natin, loop rule ka. Loop rule tayo. Okay, so tinamaan ko si negative terminal ng loop ko. Therefore, sa epsilon ko, positive siya. Kasabay ko yung current, so IR. And then, for this part, ang mangyayari ay diba, meron tayong equation na Q is equal to CV. Okay? Therefore, the potential sa kanya would be, double check ko lang, okay, minus QC, Q over C. Actually, small q. Gamitin natin yung mga variable natin. Okay, bakit negative? Kasi nandito yung plus. Dito yung plus, dito yung minus. So parang lang din, parang battery lang. Tinamaan natin yung plus sign, so negative siya. And then this all be equal to 0. Now, let's try to solve for the charge. However, I here must be in terms of Q. So dQ over dt. Okay? Solve tayo ng differential equation. Which is madali lang naman. I would just rearrange things to be like this. dq over dt. Tapos, plus q over c. Tapos, must be equal to epsilon. Okay? So, let's take things slow. dq over dt is equal to epsilon minus q over c. Okay. Ay, may nawawala. May nawawala. Yung R. Oh my God. May nawawala yung R. Sorry. Yan. Therefore, we have something like this. And then, dq or dt. Epsilon over R. Epsilon over R, constant. Diba? And then, minus q over RC. Alright. Let's just combine these two so that we can have something like this. Okay, combine ko lang yung denominator. Minus q. Okay, tama. And then now I am in a differential equation that is variable separable. Okay, so I have dq over q negative dt over rc. Okay. And then I would just need to integrate this thing to get q and to get t, q in terms of t. Okay, so integral ko would be 0 to q from 0 to time t. Okay, lagyan natin ng prime para di tayo malito. Kasi q, q, q lahat sila. Okay, so here, mag-substitute ka lang, di ba? Let u, para hindi ka mahirapan. Let u prime minus epsilon c. Therefore, the integral becomes yung du mo, derivative ng u with respect to q prime. Yung dq prime. Mag-zero na itong second term. Lalako siya sa derivative. Therefore, I could just go here and u. And then this guy is ln of u. Okay? ln of u. So, ln of u, i-revert back natin siya sa ln of q prime minus epsilon c. And then we have to evaluate na. Evaluate na from 0 to q. Therefore, this results to ln of q minus epsilon c. And then minus ln of negative. Okay? And then this could be further simplified by this. Dahil nasa subtraction ka ng dalawang logarithm, you can just divide the whatever inside them. Okay? Okay. So this guy becomes ln of, kopyahin natin sagot natin, q minus epsilon c, and then minus epsilon c. Then the right-hand side would be trivial. Diba? Integral ng dt is t. Okay, that's t minus 0. Therefore, we have negative t over rc. Ang goal natin, ginagawa natin goal is to solve for q. Therefore, we have to abolish this logarithm. And to do that, we have to do, kailangan natin i-erase lahat sila sa, erase yung mga bagay-bagay sa, with respect to e. So, e raised to ln, q epsilon c, minus epsilon c, and e raised to negative t over rc. Okay, the left-hand side would become magka-cancel yung E at Ln, di ba? So, ito na lang yung matitira yung nasa loob ng parenthesis. So, therefore, I have Q minus epsilon C over epsilon C negative be equal to, and then I could solve easily for Q. Epsilon C magiging, sige, slowly. I have here negative. So, tinaas ko lang muna yung yung nasa denominator. Then, I would still need to add epsilon C. Therefore, I could factor out epsilon C. Then 1 minus epsilon E minus E RC. And is that the answer that we need? Okay, that is the answer that we need. Okay? So, CC epsilon, ginawa mo siyang QF, which is that the charge that you can get at time t. Joke, that is the final siya. Capacitor charge. Okay, final capacitor charge niya. And then, to get the current, you just have to derivative this with respect to time. So, dq over dt. Derivative lang ito. And alam naman natin na madali lang mag-derivative ng exponential kasi 'di ba nasa memes nga 'di ba? Hindi sila tinatablan ng derivative, bababa lang yung mga bagay-bagay. Okay, so let's just try to show that. dq over dt must be equal to tatagos lang muna ako sa mga constants. Then this would be 0. The derivative of yung constant na 1. Tapos, the derivative ko to, ang mangyayari lang with respect to time, bababa yung negative 1 over RC. Then, the exponential would remain unphased. We have this. Therefore, this is just epsilon over R E negative T over RC. Okay, cancel yung negative sign. Is that what we need? Yes, okay. And then you can call epsilon over R to be I, di ba? Kasi V is equal to IR. And that is your initial current. Okay, and if you would graph these two, so Q and I, so you have here with respect to time, no? Meron kang dalawang graph, I and Q with respect to time. Ang pansin mo, charging tayo, charging ng charge. Kaya nga charging, di ba? You increase the charge. So, ayan, nakikita mo na yung charge increases over time as you charge it up. Okay? And then the current would drop down as you go along. Okay, bakit siya nagda-drop down? Bakit nagda-drop down yung current? Tingnan mo mabuti. May gap doon sa di ba? May gap doon sa loob nung capacitor mo. So, kapag na-saturate na siya, kapag puno na yung mga charge doon sa wala nang transfer na nagaganap. Kaya nauubusan ng current. Okay? Kasi di ba mag-charge up ka. So, magbi-build up ka ng mga charges dyan. May mga tumatalon-talon. Kaya sa simula, meron kang current. Okay. However, ayun nga, you can't, mapupuno siya at some time. Therefore, wala nang makakatalon. Okay. So, let's try an example. Okay. Meron ka dito, 10 mega-ohm resistor connected in series with a 1 microfarad capacitor and a battery with 12 volts. The switch is closed at time t0. T is equal to 0. The capacitor is uncharged. So, this problem yung meron tayo. Wala daw charge yung capacitor before closing the switch. Okay, so when you close the switch, magsisimula na siya mag-charge. Okay, so ayun lang yung point niya. At exactly T0, dun ka mag-charge. What is the time constant? The time constant, guys, is this factor. It's denoted by tau. Greek letter tau. Sana hindi na tayo gumabot sa ganong variant. So that is RC. Okay? Actually, kaya natin isolve ito ng mano-mano. A, time constant, tau, equal to RC. And this is just 10 times 10 to the 9. Kasi mega. Then the micro is 10 times. Hindi pala. Yung mega pala is 6. Ang giga yung ano. 9. Sorry. My bad. 6. And this is 1 times 10 to the negative 6. Therefore, cancel yung negative 6 and 6. I have 10 times 1. So that's 10 seconds. Yung time constant is in the units of seconds also. Okay? Okay. What is the fraction of the final charge? Okay. At the capacitor at t is equal to 46 seconds. Okay, kapag tinanong sa'yo yung ganyan, di ba? Fraction yung tinatanong sa'yo. Fraction of the final charge. We have QF, di ba? 1 minus epsilon, minus E, exponential RC. Ito yan. Okay, I just renamed the epsilon C as QF. Therefore, tinatanong sa atin fraction of the final charge. Therefore, divide mo lang by everything by QF. So, what we need actually is Q over QF. Parang percentage ng charge at time T. So, we're left with this on the right-hand side. Then, you just plug in things. Plug and play lang ito. You know RC. T is given as 46 seconds. Therefore, this has a value, calculate nyo lang, you will get Q over QF, which is around 0.99. Walang units kasi charge over charge, walang magiging units. You're just getting the percentage, quote-unquote, percentage of the charge. So at 46 seconds, meron kang 0.99 fraction. No? Almost full charge na siya kasi full charge ay 1, di ba? Kasi 1 would mean that Q must be equal to QF pag nangyari yung 1. Okay, and then what fraction of the initial current is still flowing at T equals 46 seconds? I just need to grab this again. Okay. So I over I naught must be equal to E negative T over RC. Tama. Okay. And again, 46 seconds, then RC would be 10 seconds. You just plug in things. Dapat maliit yung current na makuha mo. Wala ng current. Wala ng units. Okay, dahil fraction lang kinukuha mo. Almost zero, makes sense dahil full charge na siya. Okay. Next, last topic for the first exam would be discharging a capacitor. So, kunyari, meron kang charged capacitor C. Okay, so meron kang charged capacitor here and you want to release the energy. Okay, so meron kang naka-switch na open. Once you close the switch. Okay, close the switch. Magdi-discharge ngayon yung capacitor mo and current flows. Okay, current flows. So, meron mga video sa YouTube na nagdi-discharge sila ng malalaking capacitor na sumasabog yung mga pakwan. Nilalagyan nila ng mga ganyan. Wala lang, fun. Okay. So, what happens next is that you do your KVL. You actually have something like this. Gawa tayo ng ganun. Clockwise again. Negative IR Negative din yung capacitor. So, Q over C equals 0. Then, I have here my dq over dt. R must be equal to negative ng Q over C. Okay? And this is dq over dt negative Q over RC. And this is all the same as before. I have dq over Q. dq over Q. Everything is variable separable. No need to panic. We have negative dt over RC. And everything is straightforward from here. I have my Q to be E raised to negative T over RC. Is that what I need? Okay, may mga constants pa. Okay, so yung kulang ko ay, sige, gawin natin formally para mapalabas natin yung correct answer. Okay, I integrate this from 0 to T. And then from Q naught. Nagdi-discharge tayo, so may laman siya initially ng Q naught to some value Q. Okay? So prime mo naman na ito. Prime muna. And then I have here ln of Q prime. And I have to evaluate that from Q naught to Q. So this is just ln of Q over Q naught. Okay? Therefore, I have here straightforward na, no? Yung right hand side is the same as before. Then what happens is that I'm left with ln of Q negative T over RC. This is Q over Q naught E raised to negative T over RC. We get the answer that we're looking for. Okay. Yes. Yan. Okay. Ayan yung capacitor charge mo. Then you just have to derivative it again to get the current. Okay, so itong Q naught over RC, kapag dinerivative mo siya, let's denote that as the initial current. Okay? Initial current. Negative Q naught over RC. Then, kapag makita mo, since nagdi-discharge tayo, manggagaling yung charge mo from a value Q naught, then it would exponentially be dissipated in your current, in your circuit. Okay? Then the current has to increase. From 0, mag-i-increase siya to I naught kasi bigla ka mag-discharge, di ba? Then, it would go back to 0 again kasi nauubos na yung charge ng capacitor mo. So, nawawalan na siya ng pwersa para itulak yung mga current sa circuit. Okay? So, nakuha natin, sabi niya, negative yung current natin kasi opposite siya sa direction na nilagay na inassign na current. Okay, so nag-assign kasi ng current si author natin na clockwise siya. Ay, counterclockwise, sorry. Okay, counterclockwise. Tumingin pa ako sa orasan na. Oo nga, balitad. Okay, so yung capacitor mo, nagmumukha siyang battery kapag nagdi-discharge siya. So, nagmumukha siyang plus terminal dito, minus terminal doon. So, Sabi ko nga, na ginagawa ko usually, lumalabas sa plus yung current. So, pag ganun talaga yung actual current. Okay? And then, as an example would be a plug and play example again. This time is different pala. You have to manipulate things a bit. Okay, so yun, magdi-discharge ka naman ngayon. Meron kang initial charge of 5 microcoulombs. And is discharging by closing the switch at time 0. At what time will the charge be 0.5 microcoulombs? Okay. So the equation goes like this: Q naught, and then E negative T over RC. Okay. So I know Q and Q naught. Therefore, pagsamahin ko na sila. What I do not know is your time. So therefore, kailangan mo i-isolate muna sa time. And to do that, you have to abolish your exponential by taking it into a logarithm. So ln ko silang lahat. And then ln E RC. Bababa lang yung nasa exponential. Kakancel sila. So this is negative T over RC. Therefore, I have my T to be negative RC ln Q. And from here, plug and play na lang, you'd find that this is actually 23 seconds. Okay, and then the other question would be what is the current at this time? What is the current at this time? Current at that time, gamitin mo lang ito equation, I not E raised to negative T over RC. But we don't know I naught unless we transform it back to the initial, the designated formula. So this is negative Q of Q naught over. Okay, so alam natin si Q naught, alam natin si RC, so therefore we can use this. Okay, and then E raised to negative T RC. You just plug in your 23 seconds here. Diba? Kasi yun yung tanong. Hinahanap yung I at this time, at that time. Therefore, with the calculations, this results to 5 times 10, negative 5 times 10 to the negative 8 amperes. Okay. A little caution lang, no? So yung ganitong equation, negative Q naught over RC, pertains to this setup. Okay? So there are times na baka baliktad pala yung current or baliktad yung assumption sa charges nung charges nung capacitor mo, then things would change, no? Things would change accordingly. So negative sign, may negative sign na naliligaw when things change like that. Alright, ayun lang for first exam. Mag-exam na daw kayo next week. So when do you want your exam, guys? Kailan kayo bawal? Stop share ko na. Kailan kayo bawal? Kailan kayo pwede? So sabi ni yung kabilang class, may exam daw kayong Sabado, tama ba? Okay. Sabado may exam kayo. when do you suggest, no? So, may freedom of choice kayo, guys. When do you suggest na mag-exam? Do you want it Monday agad? Para, hindi, di pala pwedeng Monday kasi may akle. May akle. So, 12 to 7 p.m. is suspended. Classes are suspended. Do you want it Wednesday? Okay. Ako, flexible ako sa oras. Can do it Wednesday, Tuesday, whatever. So, pag-usapan nyo sa class, no? Pag-usapan nyo sa class na, okay, ganito yung gusto naming oras. Ganito yung gusto naming oras, ganito yung gusto naming day. Okay. So, paano daw yung exam? Yung exam, yes. Wait, ano yung parang kaya naman po, sir, kung wala naman sync by that time? Yung sa Monday? Ayun ba yung ano mo? Yung suggestion mo? Sa WED. Okay. Sige, kayo mag-decide, no? Kayo mag-decide. Kasi ako, wala akong pake, no? Wala akong pake kung Wednesday siya, Monday siya, Tuesday. You just have to, kayo na pumili. Sabihin nyo sa akin, then inform ko yung, yung teacher ng kabilang class. Okay. Ay, gusto ng mga bata ganito. Then, yung exam would be a multiple choice. Ito yung available lang at a certain time, then maglalak. Okay, sir, pwede po ba malaman anong types of questions lalabas? Did I answer your questions sa pagsabi ko ng multiple choice? Or iba yung tinatanong mo? Okay. Okay, so multiple choice siya, guys. 50 items. 25 coming from me, 25 coming from the other class. And then, syempre with solving ito. There might be conceptual, lalo na sa mga pina-reading assignment ko. Okay. Tapos meron mga trick questions as usual. Sa mga nakakalitong bagay. Okay? Anything else with any other concerns? Masaya mag multiple choice na multiple choice na exam. Kasi pwede mo gamitin yung mga sagot sa multiple choices. Yung mga choices. Ganun usually yung ginagawa kasi ginagamit ko yung mga sagot sa Yes, it's by pair again yung prob set. You can do it by pair. But again, you have to consider the cons of doing it by pair. Baka mamaya hindi mo nagagawa yung other problem and lumabas siya sa exam. Tapos, you don't know how to do this. Okay, so be careful with that. Pero ayan, by pair na para para hindi kayo mahirapan. Dahil din naman kayo physics major. You probably won't use this in your undergrad life. Okay, sa masters, baka pwede nyo gamitin ito mga pinagsasabi ko dito. Okay, how long yung exam? I still haven't asked yung kabilang prof. Pero, this is probably 2 hours. Probably 2 hours. The usual length of exams. Yes, graded ang prob set, but not required. Okay. Exams required, no? So, pag hindi kayo nakakuha ng exam, automatic kayo, incomplete kayo. Automatic incomplete. So, you have to take the exam. Yung prob set nyo, may makalimutan kayo yung 2 prob set, 1, 3, it won't matter, no? Kasi, hindi naman sila required, pero graded sila. Grade sila. Okay. Okay, so sige, another question, go. Nag-raise hand ka.
Yung sinadjust niyo po ba na Wednesday na exam? Sa 16 po or sa 23 ha?
16. Next week.
Ay,
Next week tayo
sige po.
mag-exam.
Sige.
Okay. Next week tayo mag-exam. So, sa akin, wala akong issue kung gusto nyo. Wag lang Monday kasi may akli daw eh. Baka ma-memohan kami na, ba't ka nagpapa-exam? May akli ah. Okay? So, syempre, feeling ko naman ayaw nyo rin ng Monday. Monday mag-exam kayo. Parang pagod pa in life. Okay, so you decide by the class. Then someone tells me sa Canvas, message lang ako, sir, na-decide kami na Wednesday na lang na mag-exam. Okay? By this time. Kung gusto nyo, 6 to 8 p.m., ganun. Okay? So, you have the freedom of choice. May ano tayo dito. Democracy. Okay, anything else? Anything else that you want to ask? Okay, guys. Again, my consultation is open. Sir, hindi ko na-gets yung ganito. I want to have an alternative explanation for things. So, you can ask that. Sir, what is the implication of this, that? Ano yung na simpler way of thinking this topic? Okay. Kasi usually after class, nagmumuni-muni ako. Tapos inisip ko, parang walang sense yung pinagsasabi ko kanina. So, nag-iisip ako lagi ng alternative explanation for things. Okay? And then if you are, kunyari, may nakita kong problem sa libro that you are trying to solve or trying to explore, then di mo na gets bakit ganun yung sagot. Okay, you can ask. Okay, dahil hindi ko alam kung natuturuan ko kayo na maayos, no? So, ano lang. Kayo rin mag-ano sa akin. Kayo rin, ay sorry, hindi ko na-gets. Okay. Okay? Yan, naka-record naman yun. So, that's for everyone. Sige, kung wala ng questions, kung meron man, send nyo sa Canvas. Kung hindi nyo maisip ngayon. But for now, it's done in the morning. So, let's dismiss na. Tapos, onting kembot na lang. Weekend na naman. Okay? Have a nice weekend, guys. Have a nice day also. Bye, class.